everyone's greatest fear. Word problems. That was so dorky I laughed out loud at myself. So we're going to start setting up system word problems, not solving, setting up. Tickets for a football game cost $4 for adults and $3 for students. A total of 1,787 people paid admission to the game. The total revenue from the sale of tickets is $5,792. How many of each kind of ticket were sold? So the first thing we need to do is we need to define our variables. You can always find, 95% of the time, you can find what your variables need to be by the last sentence, which is usually the question. How many of each kind of ticket were sold? Each kind. I know there are two kinds of tickets, so we're going to say X is going to be adult tickets and Y is going to be children tickets. I meant student tickets. The problem is my definition right now of my variables doesn't tell me anything about them. Adult tickets what? Adult tickets prices? Adult tickets sold? Adult tickets what? So I must put what's called a quantifier in there. I want to know how many adult tickets were sold and how many student tickets were sold. This word is almost the most important word in the definition of your variables. Make sure it's there. Now, since I have two variables, an X and a Y, I know I have to have two equations. So I'm going to look back in here and I'm going to look for two sets of information. And I see that they cost $4 for adults, $3 for students, and I sold that much money. Money must go with money. So $4 for adults plus $3 for the number of students tickets sold got me a total of $5,792. I don't ever put the dollar sign in until the end when I'm solving and I get an answer. The other piece of information they tell me is a total of that much were sold. So the number of adult tickets plus the number of student tickets total sold was 1,787. And I have set up my word problem. So for the majority of this video, we will set up word problems. I'm not going to take the time to solve them all out. I'm just going to give you a suggestion how to do it. On this one, I probably would solve by elimination, multiplying everything here by -3. The answer you should get is 431 adults and 1,356 children, but that will need to be in a complete sentence. So that would be your sentence. Second example. Zach has 24 coins in quarters and dimes. The total value is $4.95. How many quarters and how many dimes does he have? So, again, we're going to define our variables, and if you see in the last line, how many quarters and how many dimes does he have? Those are going to be my variables. So I have that X is going to be the number of quarters and Y is going to be the number of dimes. The quantifier in this example is this. I don't want to just put quarters and dimes. Quarter value, quarters, I don't know, quarters of a pie. What am I talking about? I'm talking about how many quarters and dimes do I have? The number of quarters. I can even add that Zach has. This is the most important part of setting up a system word problem. We will be looking at this and we will be taking off points for this. You must be able to define your variables correctly. A lot of times we just want to write quarters, dimes, or Q, D, whatever. But instead of calling it x, you could name your variables different letters. So you could do Q and D. Sometimes I prefer that because it helps me keep my place in the word problem. Again, since I have two variables, I'm going to have two equations. So I'm going back into my word problem and looking for some information. I have 24 of these guys. So the number of quarters plus the number of dimes that I have in my pocket has to be 24. The other piece of information I see is the $4.95. It equals $4.95. Well, I can't write X plus Y equals $4.95 because the number of quarters plus the number of dimes doesn't equal 4.95. I can't have 0.95 of a coin. So remember, this is money, so somehow I must bring money over to this side. So quarters are 25 cents and dimes are 10 cents. So 25 cents times the number of quarters plus 10 cents times the number of dimes has to give me the total money that I have in my pocket. And I have set up my system. To me, this one could either go substitution or elimination. I could multiply this whole top equation by negative 0.1 or negative 0.25 to eliminate. But the other thing I could do is just subtract this x to the other side and substitute. If y equals 24 minus x, substitute into here. The answer here would be 17 quarters and 7 dimes written in a sentence. Third, the perimeter of a rectangular floor is 90 feet. Find the dimensions of the floor if the length is twice the width. Well, these are easy to define. I know that X, I'm going to actually call it L this time. L is going to be length and W is going to be width. Whenever we're talking about a shape, I always draw a picture. So this is L and this is W. And they tell me, the first thing they tell me is my perimeter is 90 feet. Well, don't forget, perimeter 2 times the length plus 2 times the width, that's perimeter, is 90 feet. If I just do L plus W, I only do half the perimeter. I have to do 2L to get this other L, and 2W to get this other W equals 90. The other piece of information they give me is right here. The length is twice the width. Remember, in math, this is such a huge word. Is in math is equals. So I'm going to write the length is 2 times the width. And I have set up my system. This is definitely a case of substitution. If L equals this, I'm going to substitute that in for L. You would get L is 30, W is 15. Remember, there are units on here, so that would be feet, and again, written in a complete sentence. Last example. On Friday night, your limo travels for 2 hours in the carpool lane at 8 miles per hour faster than traffic to take you to the prom. The return trip takes 3 hours on the same route, traveling 3 miles per hour slower than traffic. What is the speed of traffic with a typo? Let's fix that typo. Before we get started, I'm going to change this word to homecoming. And I'm going to get on my soapbox right now and be a little serious. I've gone to one too many funerals of students that have died due to drunk driving or driving under the influence of something. So right now, please make a commitment to yourself, to your parents, to your friends, that homecoming that's coming up, you will not drink, you will not do drugs, you will just have a great time at the dance and at your dinner and at the after, whatever you do. But please, I don't want to go to any more funerals. So how do we solve this problem? We start by identifying our variables. Here's my question. What is the speed of the traffic? All right, well, t is going to be the speed of the traffic. Well, so far we've always had two variables to define. That looks like the only thing I'm trying to find, the speed of the traffic. But I do have two routes, okay? So the first thing I need to remind you is that we have a formula here that says distance equals rate times time. And here's my first guy, my first trip. My limo travels for 2 hours in the carpool lane, 8 miles faster than traffic. So that first guy, I don't know how far he goes, doesn't matter, maybe, but I do know his rate. His rate is the speed of traffic plus 8. And I know his time. He goes for 2 hours. Here's the other guy. The return trip takes 3 hours on the same route, traveling 3 miles per hour slower than traffic. So D is traffic minus 3, and it takes me 3 hours. Now what can you tell me about this distance and this distance? The distances are equal, aren't they? So I don't care that these are the same variable in these two equations. This is traveling to the prom, this is traveling from homecoming, excuse me. I have set up my equation. Hope you guys have a nice night. Last but not least, to solve this, notice that both equations are set equal to distance because the distances are equal. So I'm just going to set this equation and this equation equal to each other, except this should say t. So t plus 8 times 2 equals t minus 3 times 3.